mindful of is that of the site, and also at the stage in a male's life when spermatogenesis starts to kick in. So spermatogenesis begins thereabout during puberty, unlike oogenesis that develops or starts thereabout in that of fetal development. And also another thing that you have to look at is that of this process that it takes place in the seminiferous tubule of the testes. You also have to be mindful of that. And then we are going to be looking now at the whole process in terms of understanding meiosis in its true sense, in terms of spermatogenesis. So when you look at the process, you have to remember that we start off with a germinal epithelial cell, which is found in that of the seminiferous tubule. And from that, we have cells developing through cell maturation to those that we call spermatogonia, and that is plural. When you're referring to one spermatogonia, we say spermatogonium, and those will develop into what we call primary spermatocyte. All right, so it is maturation that will bring the spermatogonia into primary spermatocytes, and from there we start to look at the process of meiosis, or the meiotic division. So the primary spermatocytes will go through meiosis 1 to give us, partially haploid cells, and those we call secondary spermatocytes. And the secondary spermatocytes will go through the final meiotic division, which is the second division, to produce immature sperm cells called spermatids. And the spermatids will undergo a process called cell differentiation and specialization to form that of spermatozoa, or those that we call the sperm cells. So if you look at it, we can appreciate meiosis in a true sense, that when you look at spermatogenesis is just a specific form or way to look at meiosis, because the whole process of prophase 1, metaphase 1, anaphase 1, telophase 1, those would fit in right there during the first meiotic division, where the primary spermatocyte becomes the secondary spermatocyte. And then in the second meiotic division, we will see prophase 2, metaphase 2, anaphase 2, and telophase 2 taking place right there. And at the end, what we would call the haploid cells are those that are now called spermatids. But what we notice is that the spermatids, they don't have all the features of that of a sperm cell. So they are undifferentiated. So they must become differentiated through the process of cell differentiation and cell specialization to become spermatozoa or sperm cells. Am I clear enough on that? Sean, Ling, following?
Repeat what is this?
I'm asking,
Yes, sir.
is this clear enough in terms of the flow? Do you understand how meiosis is seen here through the process of spermatogenesis?
Yes, sir.
Good. So when you get a question on spermatogenesis, you have to pay attention to the different steps. So you start off with spermatogonium, primary spermatocyte. Then you start to identify the process that will lead to the next. So it's the primary spermatocyte, but the primary spermatocyte will go through the first meiotic division to give you secondary spermatocyte. The secondary spermatocyte will go through the second meiotic division to give you spermatids. And the spermatids will go through cell differentiation and cell specialization to become that of sperm cells or spermatogonia. So you want to populate the diagram if you're using a flow chart along with the products or the steps, and also the processes. So cell maturation, cell division, meiotic 1, cell division, meiotic 2, cell differentiation, cell specialization, and you do it accordingly. Also, you may want to start off by looking at an overview of spermatogenesis in terms of its site and in terms of the hormones too that are responsible. You can talk about that of the follicle stimulating hormone, that of the luteinizing hormone, and that of testosterone. How is it that these hormones function in the whole process of spermatogenesis? All right, before you outline the steps. But it's very, very important that you know the steps right through. So just for reinforcement, I'll be going over, then end this video, come back, we look at oogenesis, because we want to do it in fragments so that persons can quickly understand the steps. Following?
Yes.
All right. So we're saying that spermatogenesis is the process that describes that of sperm production in males, and it takes place thereabout during the start of puberty, unlike oogenesis that begins during fetal development. It takes place in the seminiferous tubule of the testes, where it starts off with that of a germ cell. Normally, you will not find the germ cell being represented in the flow chart, so reference can be made in terms of preliminary, discussion, or maybe a statement or an introduction leading up to your flow chart for persons to understand that the spermatogonia or the spermatogonium would have derived from the germinal epithelial cells. Then you look at it by using a flow chart to say that that diploid spermatogonium, singular, several, we refer to it as spermatogonia, would undergo maturation to form that of primary spermatocyte, and the primary spermatocyte will undergo meiosis 1, which is the first meiotic division in meiosis, and it will go through all those stages: prophase, metaphase, anaphase, telophase 1, and the end product would be that of the two haploid cell. In this case, we refer to them as secondary spermatocytes. And these two cells will undergo the second meiotic division, which is meiosis 2, to give us that of 4 haploid cells. So the secondary spermatocyte will go through that second meiotic division through prophase 2, metaphase 2, anaphase 2, telophase 2. And at the end, after cytokinesis, we would end up with 4 haploid cells, which will give us that of our 4 spermatids, and these are undifferentiated sperm cells. Now, these cells are not capable of facilitating fertilization or to carry out reproductive function, and as a result of that, they must go through that process of cell differentiation and cell specialization to become sperm cell, or what we would call the spermatozoa. All right, so as you can see, the difference between the spermatids and the spermatozoa is that we realize that it has, a very unique design to carry out its function, the inclusion of the midpiece and the flagellum that would enable the cell to, move and to swim towards that of the egg. So we can appreciate the developmental stages. All right, so this is very, very important in terms of, your understanding, through that of a flow chart. I think the best way to look at it is to use a flow chart, and by using the flow chart, we are able to follow through your understanding in explaining it. So if you are given the question to outline the process of spermatogenesis, you start off with that of an introduction, and then you zoom into the flow chart to look at how, the types of cells and how they come they become differentiated by the various processes to become that of the male gamete, the spermatozoa. All right, so we will end now, and we will rejoin for that of oogenesis.